everyone. Today our group is going to present a physics project on the topic hydraulic lift. And the group members are Sino Sunil, Nandana Nair, Helen Mariam Shiju, Alan Joshua Monachan and myself Rindu Merijan. Acknowledgement. For the accomplishment of the project successfully, many people have upon their blessings and the heart-pressed support. So we are utilizing this time to thank all the people who have been concerned with the project. Primarily, we thank God for we completed this project with success. Then we would like to sincerely thank our school principal, Mrs. Anu George, and physics teacher, Mrs. Anila P. Thomas, whose valuable guidance has been throughout the completion of this project. Then we would like to thank our parents and friends who helped us with a valuable suggestion and guidance which has been helpful in various pieces. Hereby, we thank all those who have helped us directly or indirectly in the completion of this project. Aim is to construct a simple hydraulic lift and to verify Pascal's law. Introduction. A hydraulic lift is a type of machine that uses a hydraulic apparatus to lift or move objects using the force created when pressure is exerted on fluid in a piston. Then this force produces lift and work. Hydraulic lift technology has a multitude of industrial applications like construction and in transportation. It is often implemented to operate heavy machinery or to move and to lift large objects like cars, shipping containers, etc. One of the physics equations that applies to hydraulic lift technology is that pressure multiplied by area gives force. This helps to determine the pressure exertion required on a fluid by piston to produce enough force to provide lift and to move an object. Materials required are 40 ml and 20 ml syringe, cardboard, toy, medical pipe and color paper.
Working principle. A hydraulic lift for automobile is an example of a force multiplied by hydraulic pressure based on Pascal's principle. The fluid in the small cylinder must be moved much further than the distance the toy is lifted. Pascal's principle. Whenever an external pressure is applied on any part of the fluid contained in a vessel, it is transmitted undiminished and equally in all directions. The static pressure applied to all fluids, whether gases or liquid, it is named after the physicist Blaise Pascal. It consists of two pistons separated by a space filled with a fluid. A piston or small area of cross-section A1 is used to exert a force F1 directly on the fluid. The pressure P1 is equal to F1 by A1 is transmitted throughout the fluid to the larger cylinder with a larger piston of area A2, which result in an upward force of F2 is equal to P2 into A2. As P1 is equal to P2, F2 is equal to F1 by A1 into A2. By changing the force at A1, the platform can be moved up or down. Thus, the applied force can be increased by a factor of A2 by A1, and this factor is the mechanical advantage of the device. Working. When an external pressure is applied to the 20 ml syringe which is kept outside, the pressure gets undiminishedly transferred through the medical pipe. The static pressure through the medical pipe finally reaches the platform which is attached to another 40 ml syringes. It moves upward direction and hence the toy is lifted. Then the platform attains its original position as the pressure is released from the 20 ml syringe. This is the working of the constructed hydraulic lift. The object moves up and down as the pressure is applied through the syringe. So, it is found that Pascal's law is the basic of the hydraulic lift system.
Procedure. First, using a ruler and cardboard, cut it into thick rectangular sheets. Make this as base for support. Fix a syringe inside the rectangular box and the other syringe outside. Connect one nozzle of syringe to other through medical pipe. Attach the second syringe on a piece of cardboard. When we press the 20 ml syringe, the platform moves upward, and when we release the syringe, it moves downward as a lift. Result. In this experiment, hydraulic lift has been constructed and verified that the object needed to be lifted by using Pascal's principle.
Advantages. It increases employee safety considerably. It requires a very small space and it has very less weight which would make feel comfortable. It provides user-friendly working methods. The top benefit of the hydraulic lift it is safety and comfort. The lifts are highly durable and very easy to use and maintain. Hydraulic lifts are cheaper to install than other elevator types. They occupy less space in a building, requiring almost 10% less area for the lift shaft. They are highly effective with heavy loads as the hydraulic power provides a far greater lifting strength. There is no need for an overhead machine room. Similarly, overhead structural requirements aren't needed either. The load of the elevator is distributed to load-bearing walls. The hydraulic systems are simple, versatile, and efficient for the transmission of power. The main reason for the widespread of the hydraulic lift is the benefit it provides by creating safe working conditions. This helps to gently to reduce overload of the work and the amount of injury caused to the workers due to stress. Applications. Hydraulic lifting are widely used for lifting, moving, pushing, mining, construction, and steel in the material handling equipments. Hydraulic system is popularly used in the manufacturing and production of companies that transport heavy goods and machinery by roads use lift. The forced amplification is used in the braking system of most vehicles. The lift generated on the airplane wing can be worked on this principle. This principle is also used for air pumps. Pascal law are used in hydraulic brakes, hydraulic jacks, hydraulic pumps. Pascal law are used in hydraulic brake because when brake are applied suddenly in a moving vehicle, there is a chance of vehicle to skid because the wheels are not retarded uniformly. In order to avoid this danger of skidding when the brakes are applied, the brake mechanism must be such that each wheel is equally and simultaneously retarded. Hydraulic pumps are used in hydraulic drive system and can be hydrostatic. Hydraulic pumps is a mechanical source of power to convert mechanical power into hydraulic energy. It generates the flow with enough power to overcome pressure induced by the load at the pump outlet. When a hydraulic pump operates, it creates vacuum at the pump inlet, which forces liquid from the receiver into the inlet line to the pump and by mechanical action delivers this liquid to the pump outlet and forces it into the hydraulic system.
Precaution. When pressing the cylinder system, be sure to press only the input plunger with your hand. Lift slowly and check load often. Do not use damaged or worn components. Follow the directions step by step. Use knives rather sharp pointed instruments with care. Conclusion. Hydraulic systems are used in industrial control and transmission systems. A small amount of power can lift a big load. It is a modern way to replace levers and pulleys. Hydraulic lift technology is a critical aspect of engineering without which many applications would not be possible unless another technology existed to replace it. It has contributed to a large part of the modern world. Thank you.